Bandwidth for changelog is provided by Fastly. Learn more at fastly.com.
I'm Keith Randall, and it's go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. It is episode number 27 of Go Time. Today on the show, we have myself, Eric St. Martin. We have Carlicia Pinto.
Hi there.
And then Brian Kettleson is out today, and filling in for him today is Bill Kennedy. Say hello, Bill.
Hey, hi, everybody.
And our special guest today actually taught us all how to make a lot of profit using maps at GopherCon. I'm still waiting for my check, but on the show today is Keith Randall from the Go team.
Hello, everybody.
So you want to give everybody kind of like a rundown, who you are, what you do, specifically on the Go team?
Sure. I work on Go runtime internals and compilers. So I work on making Go faster. All behind the scenes. You don't sort of see anything I do in APIs or anything like that, but every release we make things a little bit faster and a little bit less memory and all around better.
That's awesome. So you specifically work on the compiler and runtime?
Correct. So I sort of started out working on Go, working on runtime things like maps, scheduler, some of the type conversion stuff, and so on. More recently, I've been working on compiler internals, so making generated code better, smaller, that sort of thing.
No, that's awesome. So have you played a big role in the SSA stuff that's happened over the last couple of releases?
Yeah. So I started the SSA backend project, proposed it, got people on board with it, and sort of was the tech lead for it. I wrote the first prototype and then got a bunch of other people, both from inside Google and outside, to help work on it. And it was released in 1.7 for AMD 64. And then for this upcoming release, 1.8, it's going to be available on all the other architectures. So ARM and MIPS and PowerPC and so on. I think maybe even there's a Spark one coming. I'm not sure whether it's going to make 1.8.
Oh, nice.
Yeah, and the performance we get, it's on x86, it was something like 20% better. It very much depends on the application, but we're getting on average about 20% better. Mostly because the x86 chips are really good at executing bad code. So you really have to do a good job of making better code before you can see the performance improvements. We're getting something more like 40% better on ARM chips, which are not as good as hiding the old bad code. So I think it turned out pretty well overall.
Yeah, and ARM needs the love even more, right? Because ARM typically doesn't have the clock rate that an x86 chip does. So
right, absolutely.
Those performance improvements help a lot.
And those performance improvements help save power too. So that's also a big thing.
Yeah, that's true as well. So what we should probably circle back a little bit to when we talk about SSA, and just kind of like maybe give a brief explanation of what SSA is and kind of, why that benefits us to have the compiler leverage SSA. Okay.
So I guess at first it would be helpful to describe what the old compiler was like. And so the old compiler used to take the abstract syntax tree of a Go program and would generate code sort of node by node on that syntax tree. So if there was a plus, it would load both arguments into registers, do the plus, and then store the result somewhere. And it would sort of do that one at a time on the nodes of the syntax tree with no look ahead, very, very little look behind. So sort of the code it generated wasn't very good because there were a lot of moves you didn't need. There were a lot of operations that if you did the same add twice, it would execute that add twice instead of reusing the result. And so SSA instead, what it does is it takes the abstract syntax tree and builds a control flow graph and a value graph. And then we can do all sorts of optimizations on that graph, like common subexpression elimination. We can do bounds check elimination. We can do better scheduling, all that sort of stuff, dead code elimination, all of which benefit the generated code and make it better than what was generated previously straight from the abstract syntax tree. And SSA compilers have been around for a while. I know I worked on one like 15 years ago. So it's pretty mature compiler technology. GCC uses it, LLVM uses it. It's pretty common compiler technology, and this is not sort of a researchy thing. SSA is known to be a good way to generate code for compilers. Just we need to get Go up to speed so that we can compete with the other languages.
I got a quick question because I'm always trying to visualize these things that are going on. So this piece is happening inside of the compiler, and then is this helping to generate that intermediate assembly? Is that kind of where this is, or is it like where in the tool chain between the compiler, the assembler, and the linker is all this sitting?
Fair enough. So that when you start with Go code, there's a parser that basically takes that Go code and makes an internal in-memory representation called the abstract syntax tree. From there, SSA takes that abstract syntax tree and generates assembly code. It's actually sort of an in-memory representation of the assembly code. It's sort of semi-already assembled. And then that gets passed to the linker and code generator from there. So it's basically the input is an abstract syntax tree and the output is an in-memory representation of assembly.
Okay, so this would actually be an IR. Bill and I were actually kind of having this debate before the show, the difference between an intermediate representation and an intermediate language. And the best I could come up with is that an intermediate language is actually produced code, whereas IR is typically in-memory data structure. But I could be completely wrong there too.
Yeah, I don't think I've ever heard the term intermediate code.
Or intermediate language, I think.
Yeah, or intermediate language. I don't know. It's a good question. So LLVM has something which maybe I would call an intermediate language. It's an actual textual representation of the IR.
Yeah, that was my interpretation of the difference between the two. I've always heard IR, and then Bill said IL this morning, and I was like,
I think I got that from the .NET side of things over there when they have a whole intermediate language over there between what the C# compiler's producing, if I remember.
Yeah, I believe they have. It's like Java. They have some sort of bytecode thing, right?
Yeah, so the SSA is really interesting. I was just always curious if it came before or after the assembler there or somewhere in between. So, okay.
Yeah, so that there's no assembler when the Go compiler runs. There's no assembler used.
Ah, okay.
The thing that's generated from the compiler is already essentially equivalent to what the assembler produces when it parses assembly.
Oh, interesting. Yeah. So then basically there's only a linker after that, right? There's no intermediate assembly stage.
Correct.
Yeah, I think Rob Pike did a talk about that at GopherCon where he's talking about there's like a shared layer, that there is an assembler and there is the compiler, but there's like an object or some kind of library that's used between the two.
Right.
It was a while ago that I saw the video. I didn't get to watch the talk while I was there, but I remember vaguely that there was no assembly stage in the compile process.
Right. We go directly from the compiler output. It generates something called the obj library. And so it generates basically one structure for every assembly instruction. It tells you what the register inputs and the register outputs are. And then actual instruction selection, like encoding the bytes of the instruction, is done by that object library. So the compiler itself doesn't emit bytes. It emits these data structures, one per assembly instruction.
Oh, wow. Yeah. So it doesn't. So in a typical approach, the compiler would emit assembly instructions, and then those would then get turned into the actual machine code by the assembler. So you're saying that object library converts the IR directly into the machine instructions by using kind of internal data structures.
Exactly, yeah. And so our assembler is really just a parser. It doesn't assemble in that sense. The obj library, which is part of the linker, well, sort of, is the thing that actually does instruction selection from the sort of internal representation. Yeah.
Oh, interesting. Now I need to start playing with compiler internals. That's a little below where I usually work, but it's really interesting. So looking at kind of the changes and stuff, and I know that a lot of this, the work that you guys have been doing has been making it easier to port to new architectures on the back end, as far as like the assembly and stuff goes. Now, what about the compiler backend itself? Is it in theory, is it reusable? Kind of like, JRuby and Scala are built kind of on top of Java bytecode?
So The new SSA backend is very easy to port. So there's just a machine description file that has all the opcodes you want to use and a bunch of rewrite rules that tell you how to get from a sort of machine independent IR down to a machine dependent IR. As far as the compiler itself, whether you can like embed a compiler in some other program, it's not sort of directly reusable, although it's certainly more reusable than the old compiler. And that's the direction we're heading, is to get to the point where we could, if we wanted to, make the compiler a library.
I don't think I have a direct use case for that, but it's just interesting to kind of see these different languages and stuff build on top of things that other languages have done and kind of leverage that stuff where there's shared resources. So if somebody wanted to make, their own spin-off of Go that has, some wanted feature that we not necessarily is going to be brought into Go proper just yet because of the Go 1 compatibility guarantee or something. Maybe they could do like a spin-off that has it in there, but leverage all the same compiler logic.
Right. Yeah, that would be nice. Yeah.
I was curious. We constantly talk about how fast the compiler is and how we're trying to bring it back down to that when it was written in C.
Right.
But optimization's also really important. So how do you guys strike a balance about how much optimization the compilers will do as opposed to how much time that would take?
That's a good question. It's sort of hard to, there is a trade-off there. And at some point we're going to have to say no. And we have said no to optimizations that just would take too long otherwise, like alias analysis. We haven't done any yet. And we're sort of scared to go down that route because it can be very expensive. The original goal of the SSA compiler was we want to make the compiler generate code that's better enough that the compiler gets no slower because we compile the compiler with the compiler. So we sort of want to buy back all the extra time we're spending by making the compiler faster. And we didn't quite get there for x86. SSA added something like 30 or 40% to the running time of the compiler, what made the compiler 20% faster. So we sort of lost out in 10 to 20%. But on ARM, it totally works out that we get 40% back by compiling the compiler with the SSA backend, and then we spend 40% extra time. So the compiler is actually no slower with SSA backend than it used to be on ARM.
I always love how meta that is.
It is very meta. It's hard to describe.
Are there optimizations that, I guess once all this SSA stuff is done, optimizations you'd like to see maybe going forward?
Sure. And we got some of the major ones like common subexpression, which are very important. There are ones that we could do that sort of are more domain specific. So we could certainly improve our generation of floating point code, for example. We could do a better job of bounce check elimination. We could do some simple alias analysis that would get rid of some variables that would otherwise have to be stored on the stack. We could put them in registers. So there's things like that. But at some point, we're going to reach diminishing returns, right? It's not worth the extra effort of coding. It's not worth the extra runtime with the compiler to do those sorts of things. And then at some point, we're going to have to sort of declare that we're done, or at least we're done unless someone comes up with new ideas.
There's always more better.
That's true, yeah.
Well, by the time I think there's the fear that there's an end, right? But it's just like any goal in life. By the time you get anywhere close, you've drawn the line out further, right? There'll be something else that comes out and you're like, we need to do that.
Yeah, that's true. And there's always people filing bugs saying, hey, my program is not as fast as I think it should be. You guys should fix this. I have a stack of them now that I have to look at. So yeah, there will always be complaints. There's just a question of, there's limited manpower and there's limited compiler running time. So you have to be judicious about what you attack.
Yeah, I guess that's the trade-off too. It's the same thing with the language, right? The whole thought process behind the language is, how do we provide everybody what they need without providing them too much? And it's the same thing with the compiler, how do you do everything you need to do, but without having slow build times?
Right.
Every time I have to compile a C or C++ app, I want to email all of you and thank you. It's like, you forget, and then there's one day you have to work on something and build it, and you're like, oh, this is so bad.
Yeah, I had to download LLVM at one point and build it, and it took like 2 hours.
Oh.
Like, how is this possible? I mean, sure, there's some incremental thing which you can do better if you're a developer, but from scratch, it took like 2 hours to build.
I remember doing this on processors less than a gigahertz. Like, oh. I remember upgrading like GNOME or KDE back in the day, and that was like you let it run overnight.
Yeah, I don't want to go back to those days.
Same thing, 56K modems. I don't want to go back.
Our house at home just got upgraded from a 2 megabit connection to a 6 megabit connection because we live in the boonies and we're too far from the central office for anything good. But just the jump from 2 megabits to 6 megabits has been awesome.
It's like life changing.
It is. Like now, like more than one person can watch a video at a time in our house. So we're not hitting each other over the head whenever anyone else is doing anything that's ruining our videos.
It's not fighting over who can use the bathroom to brush their teeth first. It's who gets to watch their movie.
Yeah, exactly.
Like you watch cable, I get Netflix today. So, what's next for the compiler? Like, what's exciting? What do you have planned for kind of the next couple of releases?
Let's see. One of the big things that's coming, or will if it works out, is we're going to change the calling convention. So right now, when you call a function, everything gets passed on the stack in memory, and everything gets returned on the stack, and that's pretty inefficient. But it makes things like walking the stack and finding all the GC roots and things like that very easy. So we're looking at passing values in registers and returning values in registers instead. And it's sort of a big project. It's not terribly hard coding wise to get the compiler to generate that code, but it has a lot of implications for the runtime. And it has a lot of implications for like everyone who's ever written assembly would have to change their assembly. So we're sort of looking at how we roll such a thing out to make it so that everyone doesn't have to rewrite all their stuff all at once. But we think it could buy another 10 or 20% in runtime. So that's one big thing.
How much assembly would you say exists in the Go standard library and runtime?
Oh, the standard library may have, I don't know, 10,000 lines of assembly.
Wow.
It's not huge, but there's a lot of like stuff for all the big int stuff has a lot of assembly. All the crypto stuff, there's a lot of assembly. And then, you can put assembly in your Go project. So there's probably all kinds of stuff on GitHub that we don't even know about that has assembly. And that's the stuff I'm worried about. Like we can fix the runtime and the math and whatever else ourselves. But the problem is someone out there has random assembly that they're using in their project, and we don't have control over when they change that assembly and so on. So we're currently thinking about how we might roll such a thing out if it ends up working out.
Yeah, that almost feels like it's going to have to be some sort of phased approach, right? Where there's like at least a release or two to kind of give people time to convert.
Yeah, and we were thinking about, the current assembly. When we switch to a new calling convention, we can then generate stubs for all the old calling convention things. And then you can sort of opt in to get the new calling convention, and we'll remove the stub as you change your code. So something like that may have to happen.
Right.
Do you work on any of the escape analysis stuff with the compiler too?
I've touched escape analysis, yeah. I am not a major contributor to it, though. David Chase did a lot of the most recent stuff.
Oh, yeah. Okay. Yeah. There was a document that Dimitri put out a little over a year ago on some of the escape analysis flaws, and I was kind of curious how much of this has been worked on over that year, and if there's any update to kind of what's left.
I don't know. That's a good question. I know that it's another one of those never-ending rat holes you can go down trying to get every last case that people care about. I don't think anyone's been working on it seriously for the past year. So, maybe fixing obvious bugs and things, but there's been no concerted effort to cover the remaining gotchas and so on.
So I have a question for you. So we actually have a C++ app that requires real-time thread support. And over this past week, we were kind of joking about would that be something we could ever rewrite in Go? And basically, it takes MPTS streams, basically multiplexes multiple MPEG video streams together. And to keep the timeline, because it's a linear video, it requires real-time threading. So this was actually kind of like a thought experiment. And I was thinking to myself, like, you could, in theory, use syscalls to set the thread to real-time priority and lock OS thread to keep the Go routine running in that thread. But I'm wondering what other implications might need to be accounted for inside the runtime in order to kind of get like actual thread priority support.
Yeah, that's a good question. I think it should just work. That if you take a Go routine, lock it to a thread and tell the OS give that thread high priority, that should just work. You'll get pauses when GC starts and stops, but those have been getting quite low recently. And I can't think of any other reason why you wouldn't get all the cycle time that the OS is going to give you. Yeah, so that should work. As long as your program is single threaded. Once you sort of try to use multiple Go routines to do that, I'm sort of less confident it would work out of the box.
Yeah, this would be multiple threads with different priority, because you basically have some threads going out to fetch new segments of video and audio. And then you kind of have your real-time threads that are responsible for keeping your timeline and multiplexing the packets together and dropping them and accounting for network jitter and stuff like that. So yeah, it would definitely be multi-threaded. So I might have to whip up like a silly example of something like that to see whether I could get it to work and whether it falls flat. Before, it wasn't even a consideration because of the garbage collection time, but now it's nice to see that we're kind of in a point where that's not the most complex part of it, right? It's really the fact that Go routines by nature aren't really their own threads, which is to most people's advantage, but in this case, it's much harder.
Right. Yeah, there's no Go routines don't exist as objects to the users, so you can't set priorities and things like that on Go routines. And that's sort of a deliberate design decision that, they're anonymous. And so you can't do things like wait for Go routines to die and things like that.
Right.
It makes the runtime a whole lot simpler, but yeah, it makes things like real time a little bit more difficult.
But I mean, in those use cases, I mean, I'll take it, right? Like you can use Go for almost anything except for a couple of these odd use cases that not many people have to worry about.
Yeah, exactly.
All right. So we're going to take a quick sponsor break, and then we will jump back on with Keith.
Software teams use Backtrace to take the headache and guesswork out of debugging across their environments. Backtrace jumps into action when your Go application fails by capturing detailed application state information, including the complete set of Go routines, channels and their wait durations, and my favorite, scheduler information. Backtrace analyzes this state and archives it in a centralized object store, allowing you to explore interesting patterns across your errors and plug rich error data into your resolution workflows. Backtrace is used by companies like Fastly, which is Changelog's bandwidth partner, Limelight Networks, Message Systems, AppNexus, and more. Head to backtrace.io/GoTime to learn more and start your free trial.
All right, we are back. Carlicia, I know you had some questions for Keith.
Yeah, I was curious to know if you do any side project when you're not working on compilers, or if you do a different sort of compiler work when you're not at work.
Like when I'm home hacking by myself?
Yeah.
Yeah, I sort of hack on random stuff. I wrote a pretty good integer factorization library, which you can grab on my GitHub account. It can factor 50-digit integers. So I'm a math geek and a performance geek. So I like to sort of hack on stuff like that.
Very cool. I'll check it out.
Are there other languages that you work in, let's say, other than C? Like, have you looked at Rust at all? And what do you think about their philosophies around integrity and about the runtime there?
Yeah, I like the idea of Rust that, you keep track of exactly what pointers mean and what they're allowed to do and when they disappear and things like that. I'm not a big fan of the fact that there's, 8 different kinds of pointers or whatever the number is nowadays, because that adds a lot of cognitive load to the user to figure out which ones he's supposed to use where. I haven't actually written anything in Rust, so take my comments with a grain of salt. Maybe it's easier than I think it is. But I like the fact that in Go, you can just sort of, everything's natural. It's you're used to it coming from C or from Java or whatever. There's nothing sort of fancy new semantics to learn.
One of the questions that seems to come up more and more, and I think it's because I'm seeing more programmers that are coming from functional programming languages, is they get like afraid about pointers, and they start asking me, what is the advantage of having the pointers over what they're, not having to deal with them? What kind of answers can I give them? Like, do you have any opinions around that?
It's fundamentally a question of efficiency. And to the extent that a compiler can realize that you're doing something functional and can pass pointers around under the hood so you don't have to do big copies, that's great. But if I'm like, the SSA thing would totally be impossible to write in a functional language because everything's linked to everything else via pointers, and the side effects matter. Like if I want to delete an instruction from an instruction stream, I need to sort of update all the people who use that instruction. And I need to update all the people who, all the arguments of that instruction. And so there's a lot of side effect things that have to go on in order to make the compiler work and work efficiently, that I don't have to sort of iterate through all the instructions to find a single use of an instruction, for example. Yeah, so I agree that the semantics of functional languages are much easier to understand and make for a nicer programming language. In languages at scale, it's hard to make functional programs efficient in all cases. Whereas given a pointer, it's much easier to sort of design your thing to make whatever algorithm you're doing efficient.
That's cool. I'm also curious if you played with Delve at all, and what kind of support are you seeing maybe in the future to help the development of that tool?
Yeah, I love Delve. We are in contact with Derek all the time about, we're making this change to the compiler. It's going to change the layout of registers or layout of memory locations. Does Delve still work if we'll do this? And so we had a good contact with him, and I love Delve. I use it not all that much when I'm developing Go, but when I'm doing sort of hobby projects, I use Delve all the time.
That's awesome. So you actually collaborate and reach out kind of proactively and let them know that there's going to be these potentially breaking changes to kind of give them a head start.
Yeah, exactly.
Oh, that's great.
Yeah, Go had a very bad story for debuggers for a long time. And it was slowly bubbling up our list of, this is something we have to tackle. This is something we have to tackle. And then Derek tackled it for us. It was great.
One of those see a need, fill a need
Exactly.
type of things. I was actually really surprised when it came out. Like, I thought kind of to your point, I kind of thought that was a ways down the road as far as the Go team. There was still a lot of work to be done on the language and compilers themselves. And they recognized that there needed to be a debugger. It just wasn't the priority now. And then Derek pretty much came out and was like, I got one.
Yeah, exactly. It's pretty sweet.
Yeah. So speaking of kind of cool projects, you guys want to get into interesting projects and news, and we'll just kind of talk about stuff that's going on right now?
Yeah, let's do that.
Okay.
So the biggest of which is the Go 1.8 beta, which was recently released. And for anybody who hasn't tested their code against it, they should, because it drops in February, if I recall.
Yeah, February 1st or January 31st, something like that. Yeah.
And Brad Fitzpatrick gave everybody a warning that he's got time to fix bugs now, but later, not so much. So file the bug reports now. So is there anything kind of you're particularly excited about that's in this release?
Well, I mean, the big thing is SSA stuff for all the other architectures besides x86. So that's sort of been my focus. What else is cool in this release? It's a good question.
I know everybody was raving about the 10 to 100 microsecond GC pauses.
Right.
I think it was guaranteed to be under 100 microseconds, but they were seeing 10-ish most of the time, if I recall what that was.
Yeah, so the pauses we got rid of. So there's a bunch of stuff that you have to do when you stop the world. So when you do a GC, you stop the world, you sort of set some bits, then you have to do some stuff, and then you have to start the world up again. And the stuff you need to do, we've been shrinking and shrinking and shrinking. And now it's down to, just set some bits in various places and start again. You don't even need to scan a single Go-routine stack before you can start the world again. And so it's getting quite a bit better, sub-microsecond for almost everybody, and well sub-microsecond for lots of people.
And then I know this release also saw some improvements with the overhead in calling out to CGO.
Right.
I don't remember what they were. I want to say it was like cut in half or something like that, which was a big concern for people using CGO, was the expense of calling out to C. So most of the time the code got written in C, and then there were just kind of these logical breakpoints where flow of execution kind of got handed over to C. It did its thing and came back, rather than kind of more iterative, tight loop type calls into C.
Right. Yeah. And a lot of people sort of are stuck with legacy stuff in C, and you've got to use it. And yeah, so I think with the big improvements were in defer. We put some defer records on the stack instead of allocating them from the heap. And that sort of helps a lot when you basically have to do a defer every time you go into C in case something panics. You need to defer there to recover. Yeah, so that was, I think, the big thing. But in general, it got a lot of love in this release. Ian looked at it quite a bit to get the overheads down as much as we can.
So, and speaking of which, defer itself was improved. Was that kind of where this was gained? the overhead was kind of saved there because it leverages defer, and then defer itself had performance improvements.
Yeah, so that was the main reason behind the optimizations to defer, was for the C path.
So we actually have a listener in the GoTime FM channel, Chris Hines, who's asking a question for you. He's asking what the status of inlining non-leaf functions is. Because currently you can only inline functions if all the functions they call can also be inlined.
Right. Yeah, so actually we have an intern who's going to be working on that. He's started already, I believe, although I haven't seen a CL from him yet. But it's actively being worked on. And the tricky part is getting all the stack traces right when you start doing that. And so that's what he's working on.
Yeah, and that's actually what he's mentioning here. He said part of the problem is that we want to preserve stack traces, and inline functions will not show up in stack traces.
Right. So we're working on it so inline functions will show up in stack traces. And so there will no longer be a one-to-one mapping between the PC you have and the function that you were in, because some PCs will be in 2 or 3 functions nested. And so we sort of have to record all that information to be able to have runtime callers return that to you in a sensible way.
Cool. So some other stuff. I saw the race detector detects concurrent map use. And I actually didn't realize that wasn't detected before.
Right. So actually, the race detector always detected that. However, we implemented something additional in 1.6, which is that the runtime itself, even when the race detector is not being used, the runtime itself would detect concurrent map use and give you and panic, or not panic. It would actually just crash the program. But it wasn't complete. It handled some cases and not others. And we improved that in this release to make sure that we handled as many cases as we could possibly handle. So basically, it detects if you have a reader and a writer at the same time for a map, and it will crash the program, because in that situation, programs would non-deterministically occasionally crash anyway, and then you'd have no idea why they crashed, because they crashed some later time in some unrelated code. And it was a very sort of confusing situation to be in. Whereas now the map detects that you're doing that kind of thing and crashes immediately. So you can hopefully find and fix the problem before you release some code to production.
And then I think the other stuff that I saw was around plugins, some stuff for the HTTP server, some more context stuff. Plugins seem cool. I mean, as far as like readability, I think there's some concern there because you have to do some type assertion when you read from it. So it starts to look a little crazy, but I mean, the fact that we have plugins is kind of cool. And I'm not really sure how else to do that without doing the type assertions.
Yeah, it's a difficult problem, and it rears all the problems you have with Java distribution, is that now you have to distribute your plugin somehow along with your binary. But for use cases where you need it, it's really useful. And you can sort of wrap all that type case stuff into a library on the client side, so you don't have to see it, except for the person who's actually doing the wrapping.
Oh, that's interesting. Yeah, it's just kind of like a wrapper library that does the type assertions.
Right. So that's sort of how we expect it would be used. Like you have a plugin for, I don't know, some Photoshop transformation, and it takes a image and returns an image or something, right? And you just have a wrapper on the client side of that library that casts the argument to an empty interface to pass it, and cast the thing back to an image when you get it returned. And that way the client doesn't need to deal with that.
The plugins, I haven't even looked at it yet. Are you able to reload plugins at runtime, or is it when the app comes up, those are the plugins and you'd have to restart?
You can load plugins at runtime whenever you want. You just call whatever the routine is. I don't even remember its name. I don't know about reloading. I think once something's loaded, you're stuck with it.
Yeah, I'm a little concerned that people are going to start abusing. Well, I guess you can abuse anything, right? But start breaking that out. But the one area I guess always comes up with the static binary as opposed to having this is security, right? Like, oh my God, we just found a security flaw and we want to fix that, and now I got to rebuild every binary I have to do that, as opposed to just deploying maybe the new plugin. And this is like the classic argument I'm constantly hearing about, maybe the negative side of Go always just building that single binary for deployment.
Yeah, it's tough for distributions like Ubuntu or whatever. They really want to have shared libraries so that when there's a bug in the crypto library, they can just push the crypto library and not every Go binary in the world that uses crypto. Yeah, so I certainly understand the argument.
So I think it's about time for our second sponsor break, and then we can kind of get into some other cool stuff that's going on and interesting projects we've run across this past week.
When it comes to profiling and monitoring the performance of your Go applications, Stack Impact is a great service to help you and your team laser focus on hotspot profiling, bottleneck tracing, health monitoring, and more. Stack Impact gives you the necessary historical deep dive performance visibility into your Go application's execution so you can discover and resolve performance bottlenecks with line of code precision. Technically, Stack Impact makes Go's built-in profiling capabilities usable in a production environment. Stack Impact does everything automatically. There's no need to run commands or waste time specifying what to monitor. They've even put their Go agent on GitHub under the BSD license. So if you need to focus on the performance of your Go applications, check out Stack Impact. Head over to stackimpact.com/GoTime to learn more and tell them Brian from GoTime sent you.
All right. So Carlicia, you want to talk to us about some stuff you've seen?
Yeah, I wanted to mention that GoTime Go videos started to pop up on YouTube. There are 3 now, Russ Cox, Cassandra Salisbury, and Aditya Mukherjee. And hopefully the rest will be coming soon.
That one, what was that? It was like re-implementing Git and Go or something like that. I haven't watched it yet, but I saw it listed.
Yeah.
Were you at Gossip Go, Keith?
No, I wasn't.
I was there. Yeah, they built an entire, basically packaging Go so you wouldn't have to use the C libraries anymore. It looks really interesting.
What were the other 2, Carlicia, you said?
The other 2 was Dissection of Gophers by Cassandra Salisbury and Code-Based Refactoring with Russ Cox. And the Cloning Git one was the one by Aditya Mukherjee. Maybe I pronounced his name correctly. We also started having the Advent series, the blog post series on Gopher Academy blog. Those are really cool. We have one that's about timers and a really good one about contributing to Go. And that got the blessing from Brad. And there are a bunch of really good ones. It's a long list. And every day, so for people who don't know, every December, Gopher Academy does this, and every day a new blog post will go out. And anybody actually can subscribe, can volunteer to submit a post. So next year, people stay tuned and just pop in and ask around where you can put your name down for a post.
There might be space left too. Damian Guski is kind of maintaining the list of who's on what day, so there may actually still be openings yet this year.
That is a good point. I know for sure there are openings for backups.
Oh, yes. Yeah, and there was a talk at GopherCon this year too. Michael Matlub, I think it was, that did a talk about contributing too, which was really awesome.
That is true. Contributing to Go, you mean?
Yes. So Speaking of which, do you get a lot of contributions for the compiler itself, Keith, or is it mostly people contributing to the standard library?
We get a lot of people contributing to the compiler, certainly. It's sort of one of the most active portions of the development that's currently happening on Go, at least in the standard library and the runtime and so on. We get a lot of outside contributions, which is kind of nice because we only have so many people inside of Google who have time to work on this stuff. And to the extent that we can get outside contributions, it's great. We had a lot of help from Josh Snyder and various other folks early on in the SSA development, which really sort of kept us on track and kept us on schedule. Otherwise, I only work half time, so we only had 1.5 people working on it inside of Google.
Oh, so you were the only one for most of it working on the compiler?
Myself and David Chase worked on it in the early days from inside of Google, and then there were a bunch of people from outside who worked on it as well.
So here's a question for somebody who may have minimal or no compiler knowledge. How approachable is it for somebody to jump in and start trying to learn and contribute to the compiler? Is something really you kind of need a lot of knowledge about before, or is it fairly approachable for people to kind of get in and fix bugs?
It needs some domain expertise. It's not the easiest thing to jump in and touch. We made porting as easy as possible, so you don't actually need to write any Go code to port the compiler to a new architecture, or at least it's all tables and stuff. It's not stuff that executes all the time. But if you wanted to add, say, a new compiler optimization phase or something, it requires a fair amount of knowledge of, what SSA is, what transformations you could do on it, what you can't. So it's not the easiest thing to jump in and do. But the people who jumped in and worked on stuff on the compiler, I think they all had some compiler knowledge, but they were by no means experts. So I would say it's sort of a middle of the road thing if you want to jump in, and you should probably have taken Compiler 101 in college, but you probably don't need anything higher than that.
Do you have like a recommended book or something that somebody interested, not necessarily like designing your own compiler, but just for anybody who might want a better understanding of how compilers work?
Well, there's always the Dragon book, which is, I forget who wrote it, but it's a standard compiler book. My advisor, Charles Leiserson, has a great book on graph algorithms, which a compiler is basically a big bag of graph algorithms. It's all depth first traversal, breadth first search traversal, connected components, all that kind of stuff. So yeah, any good algorithms book would also be a good starting point.
Excellent. So Carlicia, what else do we have?
We have, oh, by the way, I wanted to give a shout out to Damian Grisky because he's been running the December series of blog posts for Gopher Academy, and he's doing a great job, and it's so much work. He has to get after people who promised to deliver a post and don't show up on time. I don't know how I would know that, but it's a lot of work, and if it wasn't for him, maybe we wouldn't have it, and those are really excellent posts. And also he is on Slack, and he said that there are no openings right now, but there are backup openings, and whoever submits a backup and doesn't get published as backup in December, it will get published in January for sure. So please ping him or us, and we'll direct you if you're interested for this December. Other things, there is Go Lab conference in Italy, somewhere near Florence. I'd love to go, but I can't. So if you can go, it's January 20 and 21st. There's still time to book it. What else? I ran into this because I was doing some research this week. Another thing that I wanted to mention is Dominic Honeff. Don't know if that's how his last name is pronounced. He has a blog post listing not all the tools, but at least most of the tools in the Go toolchain. And it's very neat. He also explains and give examples of how to use some of the tools, some of the most maybe complex or not as popular. That was really cool to run into.
Oh, cool. Yeah. It looks like it shows not just the things that are part of like the Go tool itself, but also, some of the other tools that have kind of come out around it, like bench compare, and then the bench visualization, where it creates the kind of SVG output of the comparing to benchmarks and things like that. That's cool.
Yeah. And the last thing on the list here is that there is a proposal for the top mod on the Golang Reddit to be Damian Grisky. And I personally think it's great. So basically what's happening is there is the Golang channel, which hasn't been very well moderated by everybody's account. And because of the Google presence there, people started thinking it was an official channel from the Golang team, and it never was meant to be. So now people are saying, well, let's just, whoever is the current mod, that person will step out and choose somebody new who can really moderate and choose new moderators. And the proposal, I think, who was the person who did the proposal? Was it Brooks?
I think it was Ross, yeah.
Russ, yes. He's proposing that Damian Grisky is the person. So if you have an opinion, hop on there and speak up, because that's probably going to change very quickly.
Is there a way to vote, or is it just, unless there's no downvotes? Like, how's that work?
Yeah, I don't think anybody has downvoted that at all. So I'm sure it's just going to happen, and it should.
It should.
Quickly.
Yeah, and it's going to be better for the community to have a real and consistent moderation up there.
Yeah, I walked away earlier this year. I walked away from Reddit. It was such poison to me that I didn't even, if I've looked at it even 5 times this year, that's a lot. So knowing Damian's going to be the top moderator, I'll definitely come back and start looking at it again.
Yeah, it's good because Reddit is actually very good. There are some interesting posts. I mean, the posts that are popping there, we see them everywhere, but there are some interesting discussions. So every once in a while, it runs amok, but it's pretty good otherwise.
So, Keith, how do you keep up with kind of like what's going on in the community? Are you mostly heads down, or do you kind of watch for projects that are kind of coming out that interest you?
I basically read Go Nuts, and that's about as much community involvement as I can take. um, but yeah, I sort of watch the project closely, and I watch Go Nuts, and that's sort of where I get my information about what's going on in the community from.
I think I'm like in too many of them, and then I end up not keeping up with any of them. But it works out because I think everybody else curates it, so I only hear about the good stuff.
Keith, what office do you work out of? And where are you based out of?
I'm in Mountain View at the main Google campus.
Gotcha.
Yeah, it seems like there's a couple different places. I know I heard I think that the New York office actually has more people working on the Go team than Mountain View does.
That may be true now, yeah. But it's about equal. I think we have 12 or 13 people here, and there's a similar number in New York, and then a couple people in Boston.
And Brad's in Seattle now, right?
Yeah, Brad's in Seattle, and we have one guy in Switzerland and one guy in Pittsburgh. There's a couple other scattered people.
And these are the people who are actually Google employees that are, full time. That's not including all the people who work for other companies who are basically being paid to work on Go.
Exactly. Yeah, that's only the Google employees.
I love that's a thing now too, right? That like you can work for a company that basically just sponsors you to work on a project that means something to them, right?
Yeah, and that's open source. That's not something that they're sort of directly competitive advantage thing with. They want to make the ecosystem better, and that's great.
Yeah, and we're seeing it a lot with Kubernetes now too. There's a lot of big companies that just basically have engineers on their staff that are full time working on Kubernetes and being paid by Intel or Red Hat or various other companies that are contributing back.
Eric, you got paid basically to fix a bug in Kubernetes too, right? Because Comcast needed it. So
And Docker, yeah.
and Docker. So
I wouldn't necessarily call it a bug, just kind of a
enhancement
pain point. As it's similar, so Keith, basically the real-time thread support, we kind of had an issue with running a real-time priority process in Docker, and that was really just kind of the way group scheduling works. Basically, Docker creates a new C group. C group gets 0 real-time runtime. Process inside container cannot upgrade its priority. So basically, it was just kind of patching Docker to allow people to supply a real-time runtime at container creation.
Right.
But yeah, kind of to Bill's point, it's kind of cool that they're like, why don't you fix it? Like, well, that works.
Yeah, exactly. It's the great thing about open source stuff is that the things that people care about, they can fix themselves. They don't have to wait for someone on high to fix it for them.
Yeah, I prefer PRs over bug reports too, and like I try to encourage that too because I think people should all try to approach the solution because sometimes a solution is better than no solution. So a lot of people will refrain from contributing, and this kind of goes back to the posts, Michael's talk and the post on the Advent series. With the contributing, a lot of people won't contribute out of fear that it's not a good enough solution to be taken in by some big name project, and they won't contribute at all. And then these types of things will just kind of linger forever because it's not a huge priority to the people actually working on that, but it may be a big priority to you. And sometimes a good enough solution is good enough to be brought in just to solve the problem for people. And it can be refactored later into something that, is more performant or things like that. I'm sure there's specific language features that nobody's going to, pull in some gnarly code for, but for most people's bug fixes, they're usually fairly trivial, and they're not going to introduce a lot of problems for the rest of the code base.
Yeah, and even if they're not perfect patches and they have problems or whatever, they often sort of spur dialogue or spur someone to think harder about the problem and end up pointing the way to a solution, if not being in the solution themselves.
So, did anybody have any other interesting news or projects they want to talk about, or do we want to move into Free Software Friday?
I don't.
I've been traveling a lot this week, so I've been kind of mostly detached. How about you, Bill?
I on my Twitter feed, I think Daniel Whitenack, who gave that talk on data science at GopherCon, he at least 2 or 3 packages a week around data science that he's kind of publishing. I mean, GoNum is the big one right now. That repo, github.com/GoNum's got a ton of stuff in it. But Daniel this week shared another repo called Go-HEP, which is high energy physics community stuff. Like, it's amazing to see the communities that are coming in that I guess were kind of exclusively Python at some point, now going full throttle into Go. So that's really exciting.
So allow me to correct you, Bill, just a little bit. It's not a repo, it's a whole organization. It's got a bunch of projects.
Oh, right.
Very interesting.
Yeah, that's what I meant. Thank you.
That is a whole industry I know nothing about, physics. But yeah, that's so awesome to see all of this stuff come in. You know, there's a lot more data science stuff. There's a lot more math stuff being done in Go, and that's awesome. And InfoSec stuff too. I've been seeing a lot more of that too start being written in Go.
Another thing that was interesting is my business partner, Ed Gonzalez, he got stuck this week on the floating point stuff, trying to compare 2 floating points that should have been identical, but were different because of binary decimals. And he found a package from ShopSpring called Decimal, which he's starting to look at to help fix all the floating point decimal numbers in Go for the work he's doing. So that was really interesting too.
Oh, interesting. And then how about you, Carlicia?
I ran into a project. I have not used it before, but it looks really cool. And I saw it was here on this document, but it was also on this newsletter, this Brazilian newsletter about Go called The Week in Go. And it is the JSON incremental digger. It's called JID. And basically you install it with Homebrew, and you can parse a JSON file. You can navigate a JSON file on the command line. So you can say, for example, node 0, and you get just that one node, and there are a bunch of things you can do. I thought it was really interesting.
Yeah, it's really cool because, have you seen this, Keith? You basically can give it JSON, and then you can kind of use, JavaScript notation to kind of traverse and dig down into the JSON file. So you can and it has like autocomplete of the properties too.
No, interesting. I haven't seen it.
Yeah. I dropped the link in the Slack channel too for anybody who's in there, because it's super cool to be able to do that.
Yeah, especially when your JSON gets large, it's really hard they tend to format as giant blobs that are hard to parse because they're all nested and so on. It'd be nice to have a way to sort of see the parts, just the parts you care about.
Yeah, that's exactly what I thought. If you have a very long JSON, you can start out by give me the count, and for whatever place in the tree you're at, and just get an idea of how many items there are.
Yeah, and I mean, like, some of the JSON gets like really repetitive, and then like you're trying to write these crazy regular expressions just so you can find the thing that you need in this giant JSON output. So, did you have a project you wanted to give a shout out to, Keith?
Yeah, we already talked about it actually. Delve.
Yes.
It's my favorite debugger now. I use it all the time on my personal projects. It's hard to use when I'm developing the compiler because often it crashes before like you've got something that you can put into a debugger. But I use it all the time on third-party stuff. Yeah, it's great. It's better than GDB is for C, which is not great praise, but that's all I care about.
People have been using GDB for C for ages now, so I'd consider that praise.
Well, I'm just saying that it's a low bar to be better than GDB is for C.
So I've spent a lot of time this past week in meetings and on planes and stuff, so I haven't been writing a lot of code, standard Linux stuff. But last weekend, I'm kind of working on like a home meat probe thing for my smoker because the wireless ones I have stink. So I'm going to give a shout out to like the whole kind of like Arduino and Maker community, because it's just ridiculously easy to just go on to some of these sites like Adafruit or SparkFun and order parts, and somebody else has already written like drivers for sensors and things like that, and I don't have to write any of them. I was able to kind of whip together something in like just a few hours rather than having to spend a ton of time writing I2C protocols and stuff like that, or I2C. This naming is hard. Every time I think I know how people pronounce stuff, I'm totally wrong. Like forever, I thought it was I2C, and then it turns out it's actually I2C.
I always called it I2C.
See? And then in Rob Pike, it like commonly throws off like goose and gorch. Like it's like every year I hear him do a talk or something, and there's like a new way to pronounce something. I was like, huh, I didn't know that's how you were supposed to pronounce it.
And now that you mentioned that, I feel compelled to mention that this week, Brian Kettison dropped a blog post on the December series of the Gopher Academy post, and it talks about the barbecue thingy that you guys did.
Yeah, so initially, that's running on a Raspberry Pi, so they're kind of two separate parts that are going to be merged. So that's actually Go running on a Raspberry Pi. That's the PID controller, and I always forget the actual acronym. It's like proportional integral derivation or something, and it basically takes a set temperature and the current temperature and calculates an error value and determines whether or not the blower needs to turn on to provide oxygen to the fire to make it heat up. And it's to keep a stable temp in the firebox of the smoker for long cooks. And that's all done in Go. And I'm currently working on the meat probe side of things. And then we're going to try to merge the two into like the ultimate Go and C and custom hardware little grill device so that we can plot out on Prometheus and all this stuff, temperatures in the grill and things like that. And who knows what we're going to do with the data, but it'll serve our purpose and it'll do better than the stuff we bought. So, and that's provided time. That's the hardest thing, is having time for these little side projects. So did anybody else have anything they want to talk about, or do we want to wrap this thing up?
Yeah, I think we're ready to wrap it up.
Yep.
All right. So I want to thank everybody on the show, especially thank you to Keith for taking time to come speak with us, and huge thank you for all the work that you do on the compiler for the language we love. Huge shout out to our sponsors for this episode, who are Stack Impact and Backtrace. Without them, we wouldn't be able to do the show. Huge shout out to all the listeners, both listening live and who will listen to the recorded version of this. Definitely share the show with fellow Go programmers. You can subscribe by going to gotime.fm. We're also at GoTimeFM on Twitter. If you want to be on the show or have questions for upcoming guests, hit us up on github.com/GoTimeFM/ping. And I think that's it. I always feel like I'm forgetting something because there's always so much to go through. So with that, next episode will be with Thorsten Ball, we're going to be talking about building an interpreter in Go, which is highly related to this. And then we're going to do basically a 2-week break over the holiday, and we will be back in January. So with that, goodbye, everybody.
Bye.
Bye, and thank you.
Bye.